Introduction to Computer Architecture and Organization prepared by Bilu.A1. Computer architecture hardware components are concerned together to form a computer system. It acts as the interface between HW and SW. It helps us to understand the functionalities of a system. It is considered first when designing a computer. It involves logic, address mode, data types, cache organization, computer architecture and organization. Computer organization. It concerned with the structure and behavior of a computer system. It tells us how exactly all the units in the system arranged and interconnected. Organization is done on the basis of architecture. It involves physical components, circuit design, adders, signals, peripherals. Computer architecture and organization. Fundamentals of computer architecture and organization definitions. Basics evolution of microprocessor, P. Definition of P. Evolution of Intel P. Computer performance models of computer system. Computer architecture and organization 2. Definitions. Basic cycle period of CPU clock. The fundamental need of time for CPU activity. Instruction. A meaningful command to be executed by CPU along with the data operands. The data operands register the fastest temporary data storage in the memory hierarchy. ALU. A digital logic circuit. A process logic and arithmetic. Point 3. Computer architecture and organization. Definitions. Basic memory on-off tetwa basis elements of a computer system, paging virtual and physical memory, MMU. Memory hierarchy. Register cache, levels, RAM disks. Cache fast static memory to hold most frequently used data / instruction multiply levels of cake. Cache coherency. Cache flushing. Cache replacement. Hit ratio for computer architecture and organization. Definitions. Basic memory, a digital data storage element. Temporary, working, memory usually made of flip-flop latches, SRAM, or transistor capacitor combinations, DRAM, permanent, storage, memory usually made of high-capacity magnetic / optical disks. Usually made of high-capacity magnetic / optical disks, hard drives, or solid-state devices, EEPROM flash, input/output, I/O. Device. A device was it a transfer data /from P. An interface controller is required /NP and I/O device, keyboard, mouse. Display. 5. Computer architecture and organization. Definitions. ArchSys. Complex instructions. Simpler compiler. Complex and large hardware. RISC-V1. Simple instructions. Complex compilers. Small and V1. Simple instructions. Complex compilers. Small and simple hardware. Pipeline. A structure just like a product assembly line process. The next task while it currently is in progress. 6. Computer architecture and organization. Definitions. Arch-scalar. Superscalar. Executing multiple instruction in a single cycle. A single CPU better utilizing computing resources effectively. SIMD. MIMD. In order. Out of order instructions can be executed in order sequentially or out of instructions can be executed in order sequentially or out of order depending on the availability of data. Issue 8 music to describe how the instruction execution should flow, determining branch targets. Branch prediction. Dual issue. Speculative issue. 7. Computer architecture and organization. Definitions. Hardware process determinist kind of layout. Asset to implement digital logic cells, CMOS, HMOS, LPCMOS, DMS. Process / feature size. Usually determined by the gate length of the transistors. 65 nm CMOS IKQ process. 45 nm LPCMOS. 65 nm CMOS IKQ process. 45 nm LPCMOS. System and chip, SoC. Integration of Turmer functional in its own a single chip. 8. Computer architecture and organization. Definition systems microprocessor, P controlling external memory and I/or required 8086 M68000 MIPS Spark Pentium, microcontroller integrated control memory and I/O on a single chip ABR PIC 8051 MSP Coldfire, microcomputer complete systems, CPU memory I/O storage, PC Mac VAX PDP SunSpark 9 computer architecture and organization. Evolution of the microprocessor 1958. The first integrated circuit in Texas, USA. Jack Kelby of TIN was from Fairchild. 1965. Gordon Moore, co-founder of Intel. Moore's Law. The NUC transistor sin and IC double years. Intel 4004. The first P1971, 4-bit Intel 8008192, 8-bit original ADCINET for Datapoint Corp. ASA CRT display controller Intel 80801974, April Altair 8800, 1975, MITS, 256 bytes of MEM, $395. Apple II. Steve Jobs and Steve Wozniak 1976. Apple Inc. Bill Gates and Alan Paul Basic 1975. GT Microsoft Corp. 10. Computer architecture and organization. Evolution of the microprocessor Intel 8086/80881978, 16-bit. 8088, 8-byte external BASIC, 198129,000 TRS Intel 8028619821 architecture 2 4-bit addressing memory protection and virtual memory 16 MBOF physical MEMA and D1G BOF virtual MEM 130,000 TRS. Onto a single chip IP/8 in 1984 IP/2 Model 50 and 6011 computer architecture and organization. Evolution of Intel's microprocessor Intel 8038619853 bits 35 MIPS, 7 MIP SUNC 25 MHz chip. Memory Paging Gond enhanced I/O permission features 4G programming model 1,200,000 TRS 1,200,000 TRS 386 plus 387 plus 8K data instruction cache paging Gond MMU Intel 80486 Intel Pentium III 1999 MMX and Internet Streaming SIMD instructions 0.25 micron 9.5 million TRS 600 MHz superscalar Arch 32K, 16K/16K, non-blocking level 1 cache 12 computer architecture and organization. Evolution of the microprocessor Intel Core i7 March 2008 Nihile Microarchitecture 3.066 GHz45 NMC MOS process 731 million up to 8 core/chip integrated memory graphics and direct media interface controllers simultaneous hyperthreading turbo boost technology. Simultaneous hyperthreading turbo boost technology. 32K instruction and 32K L1 data cache/core 256K L2 cache/core 8 MB L3 cache speculative issue out of order superscalar microprocessor 13 computer architecture and organization. Microprocessor defined in Webster integrated circuit that contains the entire central processing unit of a compute on a single chip. Another source microprocessor is a device that integrates the functions of CPU in a computer onto the COR semiconductor chip. 14. Computer architecture and organization. What are microprocessor-based systems? Microprocessors are the brain software systems microprocessors access memories and other units through buses. The operations of microprocessors are a control-led instructions stored in memories. Microprocessor-based systems are electrical systems consisting of microprocessors, memories, units and other peripherals. Memory output units, input units, bus control unit, data path. ALUREG16 computer architecture and organization. Microprocessor-based systems. The applications of microprocessors can be subdivided into three categories. 1. The first and most important is the computer applications. 2. The second is the control application, microcontrollers, embedded controllers, SC. 3. The third is in communication, DS processors, self and eSIC. Intel, Motorola, Zilog Corporation, Fairchild, and National, Hitachi, Japan, are some of the microprocessor manufacturers. 17. Computer architecture and organization. 18. Computer architecture and organization. 18. Computer architecture and organization. Classification of microprocessors. We can classify based on architecture, application type, performance, in terms of speed, power consumption. In modern PS, the best feature is from the different pieces taken to achieve the maximum performance based on architecture/instructions. At the major categories are RISC and CISC. 20. Computer architecture and organization. History of microprocessor summary. 21. Computer architecture and organization. Intel microprocessor summary. 22. Computer architecture and organization. 4004 microprocessor. 4008 microprocessor. 8086 microprocessor. Pentium 4 microprocessor. Intel microprocessor summary by diagram. Computer performance. The computer user is interested in response time, or execution time, the time between the start and completion of a given task, program. Main factors influencing performance of computer system are processor and memory, input/output controllers and peripherals, compilers, and operating system. Computer performance. Response time, latency. How long does it take to execute a job? How long must I wait for the database query? Throughput. How many jobs can the machine run at once? What is the average execution rate? How much work is getting done? Models of a computer system. Input process, CPU. Output memory, e.g. mouse, keyboard, e.g. printer. G. Primary secondary memory.